Sun Microsystems had a requirement to prepare a new programming language in order to prepare softwares for the electronic consumer devices like cable TV switch boxes, remote controllers, and so on. Okay. For this particular requirement, Sun Microsystems gathered nearly 30 members team led by James Gosling and Patrick Norton. Right. Sun Microsystems has started a project to prepare this new programming language. That project name is what? Green. Part of the Green project, Sun Microsystems wants to prepare a new programming language with the three features mainly. What are the three features? Simple, tight-coded, architectural, neutral. Simple in the sense, less execution time, less memory, less power consumption. Less execution time provides more performance. Less memory provides less cost for the end product. Less energy consumption or power consumption provides what's there? Less maintenance cost for the end product. Tight coded. Less number of finished sections and more implementation. If any programming language takes more number of finished sections to perform a particular action, then that programming language is called loose coded programming language. Best example, C, C++. Language takes less finished sections to perform a particular action, then the programming language is called tight-coded programming language. Example is what there? Java. Alright, already we have seen that. Architectural neutral programming language. If any programming language allows its applications to run under all the hardware systems, then the programming language is called an architectural neutral programming language. In 1991, Sun Microsystems started to prepare new programming language. Sun Microsystems has completed that programming language, new programming language at the end of 1992. 1991 it was started, and 1992 it was completed. James Gosling has suggested a name to the new programming language, that is Work, but Sun Microsystems has rejected that. Then later on, all Sun engineers have suggested the name Java to the new programming language, where Sun Microsystems has accepted that name. Finally, Sun Microsystems has announced the name for the new programming language is what there? Java. Where I given some point there. Why the Java name is coming there? At the time of preparing this new programming language, all Sun engineers, they used to take a brand labeled coffee. That coffee name is what there? Java. That's why they thought of it. They have given this name to the new programming language. More information, if you want to think about it, Java is one of the island in Indonesia. Then where the coffee powder and coffee trees things are going to be happen. Due to that reason only, the coffee powder was released with the name of the land. That is what their Java. Java coffee powder was used by Sun Microsystems at the time of preparing this new programming language. Because of that reason only, they have given name for this new programming language is what their Java, not any other reason. At the end of 1992, Sun Microsystems has prepared the first product on the basis of the Java programming language, that is Star 7. The Star 7 is totally a failure product. It is a remote controller actually. It was a failure product. And for this, no customer is identified until mid of the 1994. Up to 1.5 year of time, they waited for it. But no one is identified for it. It is a failure product. In the mid of 1994, internet era was started in abroad, in outside of India. In the mid of 1994, by the time www is getting very good boom, part of the www browsers are getting very good demand. Then immediately, by this, at the time of, in the mid of 1994, only one browser is available, that is what their Mosaic browser, that was provided by Mark Anderson. Who is this person actually? He is an undergraduate student, and as part of his internship, he prepared this Mosaic browser. Okay, fine, leave it. And by understanding the importance of the browsers, in the mid of 1994, Sun Microsystems wants to prepare their own browser. Immediately they started work for that new browser that was taken by Jonathan Payne and Patrick Norton. They are the two members who have taken the responsibility of preparing that new browser. At the end of 1995, Sun Microsystems has completed the browser preparation. They are given name for this browser is what their Heart Java. Right? Understand it? No? But some people are misunderstanding this. Some people are saying that in the 1995 itself, the Java was released. In 1995, Java was not released. Hard Java browser was released by Sun Microsystems. Later on, due to the request from the customers, Sun Microsystems has introduced the Java programming language in the year 1996, January 27th. I think so, maybe 23rd or 27th, I didn't remember it. But anyway, on particular date, on December, we can under December month, the Sun Microsystems has introduced the Java programming language. Right, sir. Now this is exactly the point here we can understand. Initially, that version for the Java is like what there, JDK 1.0 version. Understand it here? This is one of the version in the sense like what there, here only that language was introduced. Fine. Next one is what there, JDK 1.1 namesake version only. Again, JDK 1.2 version is a highlighted version. Huge number of changes are provided in 1.2 version. At present, whatever the Java we are understanding, among the Java, 70% of the Java was provided in 1.2 version only. In 1.0, 1.1 namesake versions only. Actually, 70% of the Java that was provided, that we are using at present, was introduced in 1.2 version only. After that, JDK 1.3 version namesake and JDK 1.4 version is also the namesake. Next one is JDK 1.5 version is the main version. Another main version. It has number of huge number of huge number of updations are provided. More and more number of updations are provided. Observe carefully. After completion of this, next one is what there, JDK 1.6 version. Then after this, JDK 1.7 version. These are namesake only. The next important version is what there, JDK 1.8 version again. Again, it's a milestone version. Understand it now. Long-term version. Next one is what there, after completion of it, JDK 1.9. Next one is what there, after this, JDK 1.10 are both are namesake versions only. Next one is JDK 1.11 version is one of the namesake, one of the long-term support, one of the important version. There, number of changes are provided. After completion of this, the next one is like what there, JDK 1.12 version and JDK 1.13 version, both are like what there, namesake versions only. Again here, the next important version is what there, JDK 1.14 is also be another important version. After this, next one is what there, JDK 1.15 and JDK 1.16, both are like what there, namesake versions only. Next one is what there, JDK 1.17 version is like what there is a long-term support is available at present. After completion of this, the next one is JDK 1.18. Alright, next one is what there, JDK 1.19. Next one is what there, JDK 1.20 even is also a namesake version. At present, 20th version as per my awareness. I didn't check it in the recently. 1.21 when it is going to be available or already available, that I will check and I will give that information to you later on. But these are the versions which are famous, which are important versions inside the Java. Understand it clearly. And one more thing I'm telling to you, some few points here. JDK 1.6 version managed by Sun Microsystems. JDK 1.7 version. JDK 1.7 version managed by Oracle Corporation. Changes we can identify now. After the JDK 1.6 version, the total Sun Microsystems hand over to Oracle Corporation. Oracle Corporation captured the total Sun Microsystems. All products of Sun Microsystems were provided to or given to Oracle Corporation. So up to 1.6 version of the Java was grown up with the Sun Microsystems. Right from 1.7 version of the Java is growing with the Oracle Corporation. Understand it clearly? Alright, sir. It's okay. Now it is completed. Next one is, after that, listen carefully. JDK 1.10 version is available, right? Up to JDK 1.10 version, the plan of releasing the Java is what there, up to yearly releases. 2 years once, 3 years once, 5 years once. a new version is going to be released. That is what their yearly releases up to that. But right from 1.11 version onwards, for every 6 months, a new version will come. Right from 1.11 version onwards, for every 6 months of time, a new version will come. That means monthly releases. Monthly releases. Every 6 months of time, once a new version will come. Understand it? What I am telling you now. Then after this, after completion of this particular point here, next one is, alright sir, right from Java 11th version onwards is a licensed for the corporate users, not for normal users. Those who are working with the companies, if any company wants to use Java, they must take license. Get my point? Right from which version of the Java? 1.11. It is not licensed for the students and for the teaching, for the like individual development. At your home, if you want to prepare some consultant projects, all right, there it is not required to take license. But those who are using in the companies, if any company wants to use Java, they must take what their licenses now. Right, sir. So these are the releases that we can identify clearly. Okay, fine. So this is overall the evolution of the Java. Then what versions are available, which versions are main versions, and which versions are namesake versions. That information here we are getting. Okay, leave this point here. After completion of this, today the topic now I'm going to start the second topic in Java here, Java introduction part. The second topic is like what there differences between Java and others. Differences between Java and others. All of you observe carefully. What exactly these differences are available about the Java and others? If we observe this now, everybody understand it clearly. The very first difference here we are going to understand C and C++ are static programming languages. C and C++ are static programming languages, but Java is a dynamic programming language. Java is a like what there is a dynamic programming language. Now understand it clearly. Java is a dynamic programming language. What exactly the meaning of C and C++? They are static programming languages, and Java is a dynamic programming language. What exactly the difference actually? Before going to understand this particular difference, no. First, we have to understand what is a static programming language, what is a dynamic programming language. What exactly the meaning of these two now? So, before going to start this total content here, I want to give some basic introduction content here. Now, try to understand this introduction here. All of you observe carefully. Right, sir. It's okay, fine. Everybody understand these points, no? For example, I've taken a program here. This is a program, maybe C program or maybe anything, whatever it may be, some program here I've taken. Understand it. No need to think about it. It's like what there, a C program. Dot C. C program in the sense that extension should be like what there, dot C. Fine. Here we have written a set of instructions. A set of instructions. For what purpose we have written this program actually? What is the requirement of writing this particular program? Why we have written this program actually? If you come for this point, answer is very clear. Just for the sake of getting outputs only, to generate outputs only, here we have written this program. Okay. Now just to provide like what their outputs. To generate these outputs only here we are getting this program. Fine. But how we are going to get output from this program? We have written program is okay. But if we want to get output, we have to execute that program or not? We need to execute that program or not? But without executing program, how can we expect the outputs from this program? Clear to all of you? Right. Now observe carefully. If we want to get output from this program, there we have to execute the program. Here we have to execute the program. Right. To execute this program, here what we have to do there, an engine we have to use. This is like what I am telling to you, execution. That execution here we are going to provide. But how this program is going to be executed? By using a separate engine. That engine is what there? C engine. By using C engine, we are able to execute our program. Fine. So first of all, what we have to do there? First of all, we have to provide whatever the program we have written, that program here we have to provide to the C engine, where C engine has to execute our program. Then we are able to get some output like what the required output, expected outputs here we are getting clearly. This is exactly the process here we have done. But there is a small problem here in this process now. Now tell me, all of you now tell me. Here we have written C program. Okay. How we have written the C program? In our understandable language, we have written C program. Am I right or not? In our understandable language. Our understandable language is what they're actually high level language. Our understandable language what they're high level language. Okay, fine. In a high level language here, we have written this program. Observe carefully. Any example for this high level language actually? If you understand it, int I is equal to 10. This is what their high level language representation. Int I is equal to 10. That is high level language. Where we can understand clearly int keyword I is a variable is equal to is an operator 10 constant value semicolon. Clear. Alright, if we observe this C engine is not a developer. C engine is different. So what this C engine is able to understand actually, the C engine is able to understand low level language. In the low level representation only, the C engine is able to execute the program. The C engine is able to execute the program which is available in what their low level representation. Okay, what is that low level representation actually? The low level representation is available in the form of like what there? Zeros and ones only. The low level representation is like what there? Zeros and ones only. So here int I is equal to 10, but the C engine is able to execute the program in what there? Zeros and ones only. These are the situations here we can understand. Now observe carefully. If I give this C program to the C engine, is it possible for C engine to execute our C program? I have written my C program in high level, but C engine requires the program in which level? Low level. If we provide this high level program to the C engine, is it possible for C engine to execute our high level program? Not possible. Definitely not possible. It is not possible. Okay, our program is not going to be executed. It is not possible. There our program is not going to be executed. Right, observe carefully. Exactly in this particular situation, how we are going to execute our program. But still I want to run my program. How it is possible to execute our program? That's the question. How it is possible to execute our program in this particular situation? Now, I'm giving some clarity. Observe carefully. Exactly in this particular situation, if you want to execute the program, there we need a translator to convert the program from high level representation to low level representation. Here we need a translator to convert the program from high level representation to low level representation. Right, exactly. Now here I want to take a translator. This is the translator here I'm going to take. Okay, fine. Now this is a translator, we can understand it, no? Now, what we are going to do there, whatever the program here we have written, that program we are providing to the translator. What this translator is able to do now, this translator is able to translate the program from high level representation to low level representation. After that, this translator is able to convert the program from high level representation to low level representation. That low level representation program will be provided in the form of a separate file. In the form of a separate file, that separate file is what? .exe file. That separate file is what there? .exe file. Now, inside this .exe file, what exactly the data is existed here, you can understand clearly. The data should be like what there, like this. Here we are able to have the data like this. What type of data is available here? No, zeros and ones. All right, this zeros and ones is nothing but what? What it is actually? It's a low level representation or not? The zeros and ones data is nothing but like what there? Low level language representation or not? Exactly, this is like what there? Low level language representation. Understand it clearly? Fine. Whenever we are getting this low level representation, if we provide this low level representation to this C engine, automatically the program execution is going on. The program will be executed successfully. After executing that program, there we are able to get like what there? Some outputs here we are getting. After executing our program, then we are able to get some output. Now, in this process here, we are getting output. We have executed our program and we are getting output from our content. Is that clear? All of you are getting clarity on this, no? Fine, leave this one. Alright, sir. Now here C program we have created. The C program we have provided to this translator. Translator will convert the program from high level to low level. When low level program is available, that if we provide to the execution process there, C engine will execute it. C engine is able to provide what there? Some outputs. This is the overall scenario here we have to understand. Got it or not? Now observe carefully. What is this actually? What is this actually? It's a translation process or not? Alright. What exactly the translation process here we have done to translate the program from high level representation to low level representation? That translation process is called as compilation. The translation process is called as what there? Compilation. Right, sir. Now tell me, exactly now, tell me, all of you understand it, no? What exactly the purpose of this compilation? What exactly the requirement of the compilation? You have to give answer for it. The purpose of the compilation is what there? Translating program from high level representation to low level representation. This is the very first responsibility. Compilation in the sense translating program from high level representation to low level representation. Got it or not? Good. Next one is, after that, one more point. All of you understand it now. Who has written this program, sir? Developer. Am I right or not? Who has written this program? Developer. Who is this developer actually? Is it? Human being, right? Not a god, not coming from any other planet. Just is a human being, right? What is the fundamental right for a human being? Fundamental right. Committing mistakes. Am I right or not? Doing mistakes is a fundamental right. Without having mistakes, nobody is available. Even if we call James Gosling to write Java program, in his program also a number of errors will come. Understand it now? So our fundamental right is what there? Doing mistakes is our fundamental right. Okay, getting mistakes is not at all a crime. Having mistakes is not at all a crime. Having errors is not at all a crime. But without checking our mistakes, trying to execute the program is a crime. All of you get my point or not? Without checking our mistakes, trying to execute our program directly is a big mistake, is a crime. So what I'm telling there indirectly, whenever we have written program, before going to execute our program, first check whether our program contains errors or not. First we have to check whether our programs are having errors or not. If you are having errors in our program, correct it and again execute it. Again recompilation up and again recheck it and again execute the program. If you are not having errors, no, directly go for execution. Got my point or not? So first of all, we have to check that errors are not. All right. In this overall process, who will check the errors? If you understand this point here, the same compilation will take the responsibility of checking errors. The compilation process will take the responsibility of checking the errors. The next one is what there? Checking errors in the program. Checking errors in the program. This is the second responsibility of the compilation. Again, now tell me, compilation is for two things. One is what there? Translating program from high level representation to low level representation. Second one is what there? Checking errors in the programs. These are the two responsibilities of like what there? Compilation. Is that clear? All of you get my point now? Clear. Observe carefully. One more point here I'm telling to you. Everybody put more concentration. For example, if I write a program into I is equal to 10. This is my program I have written. Everybody understand it clearly. Int I is equal to 10. I have written it. What is going to be happen there internally? When I write this int I is equal to 10, we can understand it. First, I variable will be created. To that I variable, 4 bytes of memory will be taken. For that I variable, how much memory will be taken here? No, 4 bytes of memory will be taken. 1 minute. 4 bytes of memory will be taken. Inside these 4 bytes of memory, that initial value 10 is going to be taken. Maybe 4 bytes of memory or maybe 2 bytes of memory. That depends on the programming language, whatever it may be, but assume it some memory. Some memory is going to be created for I variable where the 10 is the value will be provided. Yes, sir. All of you are getting it or not? Up to now, int I is equal to 10 we have taken. Then with respect to this I variable, what we are getting there? For I variable, some block of memory will be created where the data 10 is going to be stored. Clear? All of you are getting clarity? Listen carefully. Almost, sir, we are coming to the conclusion. Memory allocation is going on for the variables in programming languages. If the memory allocation is provided at compilation time, what? If the memory allocation is provided for the data at a compilation time, then that memory allocation is called static memory allocation. If the memory allocation is going in at compilation time, then that memory allocation is called as what there? Static memory allocation. Everybody understand it clearly. Similarly, if the memory allocation is going on for the data at a runtime, if the memory allocation is going on for the data at a runtime, then that memory allocation is called dynamic memory allocation. That memory allocation is called as what there? Dynamic memory allocation. Okay. Now tell me, how many types of memory allocations are available? Two types. What are the two types? No, static memory allocation. Second one is what there? Dynamic memory allocation. Tell me, what is static memory allocation? What is static memory allocation? Static memory allocation is a memory allocation which is performed at the time of compilation. What is dynamic memory allocation? Dynamic memory allocation is a memory allocation which is performed at the runtime of the application. Static memory allocation and dynamic memory allocation. Nice. Listen carefully. One more point. If any programming language performs static memory allocation, if any programming language is following static memory allocation, then that programming language is called as static programming language. That programming language is called as what there? Static programming language. If any programming language is following dynamic memory allocation, then that programming language is called dynamic programming language. Got or not? If any programming language is following static memory allocation, then the programming language is what there? Static programming language. If any programming language is following dynamic memory allocation, then the programming language is what there? Dynamic programming language. Examples for static programming languages are what there? C, C++, comma, Pascal, and so on. All these are examples for what there? Static programming languages. Examples for dynamic programming languages are what there? Java, Python, .NET, and so on. All these are like what there? Examples for what there? Dynamic programming languages. That's it. Our difference is very clear. Tell me, in the form of this diagram, everything I provided here. Now check it, what exactly the content here I have given there up to now. Understand it? Now tell me what exactly the content here we provided here. We understood here. Right, what is the point actually? Tell me, sir, what exactly the point here we are discussing there? C and C++ are static programming languages, but Java is what there? A dynamic programming language. That is a question. Got or not? Now, I want to give clarity on it. For that, I given the diagram, required information I have given inside this particular diagram. Let us see this one. All right. If any programming language follows static memory allocation, then that programming language is called a static programming language. Then the programming language is called as what there? Static programming language. Examples, here we can understand like what there? C and C++. Then I'm going to give some clarity. In C and C++ applications, memory will be allocated for the data at the time of compilation only, not at the time of runtime, not at the time of execution. Observe carefully. Because of this reason, C and C++ are what they're? Static programming languages. Next one is, what next one here know? If any programming language allows dynamic memory allocation, or maybe if any programming language follows dynamic memory allocation, then that programming language is called a dynamic programming language. It's called a dynamic programming language. Examples for this dynamic programming languages are like what there? Java, then what next one here? Python, of course, .NET also, and so on. These are the dynamic programming languages. In Java applications, memory will be allocated for the data at a runtime only, not at the time of compilation. Memory will be allocated for the data at the time of execution only, at runtime only, not at compilation time here. Right, sir? Now this is the point, and the related diagram also we have given. Are you getting it or not? So this is the total analysis here, what we are getting about our content. Clear? All of you are getting clarity on this point now? Okay, fine. Leave this punch here. After this, after completion of this, this is the first point, first difference. C and C++ are static programming languages, but Java is what there? A dynamic programming language. Leave this one. Now the second point, the second difference here I'm telling to you. Preprocessor is required in C and C++, but the preprocessor is not required in Java. Preprocessor does not required in Java, but preprocessor is required in what there? C and C++. This is that another difference here we have to understand. Fine, good. All of you observe carefully. First of all, before going to understand whether preprocessor is existed or not existed, preprocessor is required or not required, before all these discussions, first of all, what is preprocessor? What is the location of the preprocessor in our programming languages? Where preprocessor is existed, and what is the role of the preprocessor in programming languages, that we have to understand clearly. Understand it, what I am telling you now. What is preprocessor and where preprocessor is available? What is the role of the preprocessor? Everything here we are going to understand. Now let us understand this content clearly. I want to show in the form of diagram here. Try to observe carefully. Fine. All of you listen carefully. Fine. For example, first of all, I want to take a program, a simple C program here I want to take. This is my C program. Whenever we want to say it's a C program, there .c that we have to provide, that file extension .c. Clear? Next one is, I want to perform compilation. So here I need to perform like what there? Compilation. If you want to perform compilation, here this is compilation. Okay, fine. After the compilation, there we are able to get some file. What file here we are able to get now? Tell me. Yes, perfect. .exe files here we are able to get. All right, sir. It's okay, fine. .exe file that we are getting. Clear. After getting these .exe files, next one is what there? We have to execute the program. For execution purpose here, we have to use separate process here, execution process. All right. Now here we need to provide execution process. Execution process is existed here. After executing our program, there we are going to get what there? Some outputs. Now here we are able to get what there? Some output. Output values here we are able to get. Now output. So this is the overall concept here what we are using. And one more thing. Fine. Now, it's okay, fine. Now this is the total process here what we have done. Same diagram. Previously, whatever the diagram I shown there, same diagram here I repeated, no? But in a virtual direction here, I given this diagram. The total diagram I have given in a virtual direction. Understand it clearly. Fine. Next one is what there after this, after completion of this, another point here we are going to understand. See this. Now I want to go for compilation process. What is available in a compilation? Just I want to check this. Compilation process here I want to use. I want to provide. If you observe this compilation process here, in a compilation overall 4 phases are available. Inside the compilation overall 4 phases are available. Don't think about it. The total compilation will be performed by only compiler. Along with the compiler, 3 more missions are working. 4 missions work effort is what their compilation. What are the missions here? The very first one is what their preprocessor. Very first one is what their preprocessor. And the second one is what their compiler. Second one is what their compiler. Next one is what their assembler. Third one is what their assembler. Next one is what their loader, link editor. Loader and link editor. This is last one. As a first of all, compilation process is divided into 4 phases. What are the 4 phases or 4 missions effort now? Preprocessor, compiler, assembler, loader, link editor. Got it or not? Next one after this. Now here, anyway, my required information here I'm getting there. Preprocessor. What is the location of the preprocessor? That's my question. Here the location of the preprocessor we understood. The very first phase inside the compilation. Location of the preprocessor is what there? Very first phase in the compilation. Okay, fine. Anyway, we are having discussion now about these phases of compilation. So I want to elaborate this compiler internal structure also. In the future, I require that. That's why I'm going to use that. Compiler internal structure also here I want to use. All right. Now try to understand it now. In the compiler internal structure, what we are getting there, observe carefully. In compiler internal structure, if you understand it, nearly how many phases are available here? Here we are able to have nearly 6 number of phases. What are the 6 phases here we are able to have there? Understand it clearly. That's it. Now overall 6 phases here we are getting. What are all these 6 phases actually? No. All right. Now each and every phase is dependent on the other. I'll give their names also. Here what phases are available if you observe this. Right. The very first one is like what there? Lexical analysis phase. And the second one is what there? Syntax analysis phase. And the third one is what there? Intermediate code generation. Next one is what there? Code optimization. Code optimization. Code optimization. Next one is no. 1 minute. Semantic analysis phase is missing. All right. The next one is like what is it? Semantic analysis phase. All right. Last one is what is there? Code generation phase. Right. Overall, these phases are available inside the compiler. This is the overall compiler internal structure. One time, please check this total content here. What I have given now. Check this entire content here. First here, what we provided here, .c file, compilation, .exe file, execution, output. Compilation, if you check now, 4 missions are available. What are the 4 missions here now? Preprocessor, compiler, assembler, loader, link editor. Inside this compiler, how many phases are available? 6 phases are available. What are the 6 phases here now? Lexical analysis phase, syntax analysis phase, semantic analysis phase, intermediate code generation, code optimization, then finally code generation phases. These are overall phases here what we are having clearly. All right, so now my required point is like what there. Where is our actual required content here? If you observe this now, preprocessor, that is our required content. Preprocessor is our required one. Where is the location of the preprocessor? Preprocessor is available the first phase in the compilation. Right, sir? Now let me copy this part here. I want to paste it. Later I'll provide the required information here. So this is a diagram here I provided. Now observe carefully. Preprocessor is a tool existed in the compilation as the first phase. Preprocessor tool exists in the compilation as the first phase. Good. But what is its requirement actually? What is its requirement? All right. Now tell me first of all of you understand it, no? In a C and C++, the complete predefined library exists in the form of header files or not? Yeah, even if you are not aware about C and C++, no need to worry for it. In the form of a header files only here, we are able to get the data. In a C and C++, the complete predefined library exists in the form of what files here? Header files. Nice. Examples. What are the various header files here we are having there? Now, understand it clearly. stdio.h. Next one is what there? conyo.h. Then what next one here after this? math.h. Like this, here we are having some header files. Am I right or not? All right, sir. stdio.h, conyo.h, math.h. Okay, fine. After this, after completion of these header files, here, observe carefully. In a C and C++ applications, if you want to use predefined library, then we have to include the header files to the C and C++ programs. Right, sir? Am I right or not? In C and C++ applications, if you want to use the predefined library, then we have to include the header files in the C and C++ programs. To include a header file in the C and C++ applications, then C and C++ applications, then we have to use hash include statements. Yes, sir. What statements here we have to use there? Hash include statements. Examples here I'm telling you, observe carefully. hash includes stdio.h, hash includes congu.h, hash includes math.h. Like this here, we are able to provide. Yes, clear? All of you are getting clarity on this point now? Fine. Listen, all of you listen carefully. In C and C++ applications, if you want to use a predefined if you want to use a predefined library, then we have to include the header files to the C and C++ programs. To include a header file in C and C++ applications, then we have to use hash include statements. Examples are what there? Hash include stdio.h, hash include congu.h, hash include math.h. Like this here we provide it. Perfect. Now understand it clearly. If I prepare a C program with this hash include statements, and if I compile a program in the sense, we will be reacted first one, we will start its process first one, preprocessor will start its process first one or not. In a compilation, which one is the first one? You know, preprocessor. Then preprocessor will start its execution first or not. So now the point is like what there in this scenario here. What is the point I'm telling to you? All right. If we execute or if we compile a C or C+ and C++ program, C++ applications, then the preprocessor will be activated, and the preprocessor will perform the following actions. What actions this preprocessor is able to perform actually? If we compile C and C++ applications, then the preprocessor will be activated and the preprocessor will perform the following actions. What exactly the actions that preprocessor is able to perform there? All of you observe carefully. Point number one. Preprocessor will recognize all the hash include statements. Then what? What next one? Preprocessor will take all the provided header files names. Preprocessor will take all the provided header files names. Okay, and the preprocessor will check whether these header files exist or not in the C and C++ softwares. Please check, sir. All of you understand it now? First of all, preprocessor will recognize hash include statements. Preprocessor will take the header files names from the hash include statements. Are you getting it or not? Okay, fine. Preprocessor will check the header files names from the hash include statements. When preprocessor is checking, okay, after taking these header files names now, preprocessor will go to C and C++ softwares. In C and C++ softwares, preprocessor will check whether these header files are existed or not existed. Okay, if these header files are not existed, all of you are getting clarity up to now. It will check internally inside the C software whether these header files are available or not. If the provided header files, are not existed in the C and C++ softwares, then the preprocessor will raise an error. Understand my point, Kenu? If the provided header files do not exist in the C and C++ software, then the preprocessor will raise an error. That's okay, fine. Not available, error will come. If the provided header files exist, 1 minute. If the provided header files exist in the C and C++ softwares, if the provided header files exist in the C and C++ softwares, then the preprocessor, what preprocessor will do now? Observe carefully. Then the preprocessor, what it will do? Observe carefully. Then the preprocessor will load all the header files content to the memory. If the preprocessor is not existed, sorry, if the header files are not existed, error will be raised. If the header files are existed inside the C software, then preprocessor will load these header files content to the memory. Is it all of you getting it or not? Okay, fine. Next one is watch. Now here I am giving some points here. Observe carefully. One small note here I am telling to you. Loading predefined library at the time of this entire thing is going in at compilation time only. Please remember this. When we start compilation, what preprocessor will do? That I am giving clarity. Loading predefined library at the time of compilation is called static loading. If we perform anything at compilation time, then that is what they're static loading. Loading the predefined library at the time of compilation is called as what they're static loading. Remember this point here. Now I'm coming for the conclusion. What is that conclusion here? No, preprocessor is required in C and C++. Why preprocessor is required in C and C++? What is the need of this preprocessor in C and C++ applications? If we take for this, no, to recognize hash include statements in order to load header files content to the memory, we required what their preprocessor. Yes, sir. All of you get my point or not? In C and C++, preprocessor is required because of two reasons. What are the two reasons? No, first one is what there to recognize hash include statements and to load the provided header files content to the memory. Right. Coming to the conclusion. In a C and C++, preprocessor is required. In a C and C++, preprocessor is required to recognize all the hash include statements, and to load all the header files content to the memory. That's it. This is the reason why what is required here. No, we required preprocessor. Come again. What exactly the points can I discuss with you? Know? First of all, our point is what, sir? Preprocessor is required in C and C++, but preprocessor does not required in Java. That's the content. For that, I started with the preprocessor. Where is the preprocessor? What is the purpose of it? Preprocessor is a tool that existed in the compilation as the first phase. Leave it. In C and C++, the complete predefined library is existed in the form of the header files. Examples for header files are what there: stdio.h, conu.h, math.h. In C and C++ applications, if we want to use the predefined library, then we have to include the header files to the C and C++ programs. To include a header file in the C and C++ applications, then we have to use hash include statements. Hash include stdio.h, hash include conu.h, hash include math.h, and so on. If we compile C and C++ applications, then the preprocessor will be activated and the preprocessor will perform the following actions. What actions the preprocessor is able to perform there? Preprocessor will recognize all the hash include statements. Preprocessor will take the provided header files names and the preprocessor will check whether these header files exist or not in the C and C++ softwares. Next one is what there are for these. If the provided header files do not exist in the C and C++ softwares, then the preprocessor will raise an error. If the provided header files exist in the C and C++ softwares, then the preprocessor will load all the header files content to the memory. Notice what there, loading the predefined library at the time of compilation is called as static loading. In C and C++, preprocessor is required to recognize all the hash include statements and to load all the header files to the memory. This is exactly the requirement of like what there preprocessor in the case of C and C++. Sir, all of you are getting it or not? But the related point is what the next point, no. Preprocessor is not required in Java, not available in Java. Why it is not available in Java? Why it is not required in Java? That we have to understand clearly. Okay. So do one thing, then time may not be sufficient to continue the remaining parts here. Minimum, I required minimum 20 to 25 minutes of time actually. But I have some other class at 6:30. Can I continue the remaining part in the next class? Yes, understand it now. Actually, I can continue that. I want to, actually, my thought is also I want to complete it, but time may not be sufficient. Within 5 minutes, it may not be completed here now. So I want to continue this part in the next class. When is the next class now? Monday. No class on tomorrow at a starting mode in a few 1 or 2 weeks of time. Maximum no class on Sunday, but after that, once whoops, if I start there, definitely we are going to have classes on weekends also. Definitely I'll plan for the classes on weekends also. Okay, but not immediately. After 1 or 2 weeks of time, I'll start it. So tomorrow no need to come for the class, and day after tomorrow we'll have the class there, and day after tomorrow I'll go for continuation of this. I'll explain 5 minutes up in this entire content. After that, I'll move on to the continuation part. Day after tomorrow class is very, very important. Why? Because after this topic I will finish it anyway. After that, I will start the content like what? C and C++ are platform dependent programming languages, but Java is a platform independent programming language. Why? How C and C++ are platform dependent, how Java is a platform independent. The topic we are going to understand. Very, very important. Getting some knowledge over this particular point here. So without failure, try to attend for the class on Monday. Okay? That's it. Thank you. That's all for today. We'll see you on Monday. Thank you.